Hi everybody, I'm going to have a look at compound interest now. If you haven't looked at the simple interest one first, it's a good idea because I'm going to pretty much follow on from it. So compound interest calculations calculate interest accrued over time. A spreadsheet is a good way of showing how compound interest calculations change from, or are different from simple interest calculations. So in this case, we're going to calculate the interest accrued over 5 years on $2,000 at 5% per annum, but this time it's going to compound annually. So when we use the word compound, it means that the interest is going to change each period in each calculation we do. So in the first year, it's the same as the simple interest calculation. Start with $2,000, 5% gives us $2,100. But now, instead of just using that same interest calculation throughout, we're going to recalculate interest each period. So we take the $2,100 and multiply it by 5% again, and we're going to see that the interest increases a little bit. And we end up with 2205, so on and so forth. And we see that the simple interest calculation, we only achieved, actually I can probably bring that up quickly, $500 of interest. But in the compound interest calculation, we get a little bit more interest because we're getting interest on interest. The $100 that we achieved in the first year now accrues interest in its own right, and we would get an extra $5 of interest from it. So if we do that, we can see that we get $552.56 interest, and we end up with $2,552.56 in the bank. Now we can see that on a graphics calculator. Here's where we finished up with simple interest. Now, as I said, the only real difference was that instead of just using the same interest value each time, we now use this formula all the way down. So I'm just going to fill range that down to 60. And, oops, what I should have done first was taken out the monthly component because we're still doing it yearly. And I will fill range that instead. And there we go. We get the same values in our table here. End up with 2552.56 after the first 5 compounds. We can also use this equation here. AN equals A0, 1 plus R over 100 to all to the power n, which is the compound interest formula. A0 is our initial amount. R divided by 100 is our interest rate. And N here is the number of periods. So if we stick this into our calculator, scientific calculator, we will get out 2552.56 as per our spreadsheet. If we want to work out the interest component, we take the final amount, subtract the principal, which is what this says, or the final amount, take the initial amount, which is the same thing, said a different way. Done it here, and we get 552.56, which is the interest amount. So far, so good. Now, the problem with compounding interest problems is that they tend to not compound at the same rate as the rate or as the time. So in this case, we are compounding monthly. We've been given the rate as an annual figure. Per annum just means per year. And we're going to do it over 5 years. So if it's compounding monthly, we're going to have 60 periods. 12 times 5 is 60, 12 months in a year, 5 years. And we're going to have to divide the interest rate by 12 to get how much interest to apply each month. So here's the interest rate amount, 5 divided by 12. That'll give us the rate. Gone a bit far here. We don't need to do that yet. Which is 0.4167, and then we divide that by 100 when we do the interest calculation to get it as a decimal. And with our interest periods, we know we start with 5 years. There's 12 months in a year, so we're going to have 60 different calculations, 1 per month. And here's the first 2 rows, and then I just extrapolated it and gave you the last row. If we add up this column, we'll get the interest, 566.72, and there's 256672. We can see we're earning more interest if we accrue that was over 4 periods. So this is actually over the same period of time, over 5 years. Over 5 years we earned 552 interest if it was calculated yearly. If it's calculated monthly, we earn a little bit more, which is quite nice. The power of compound interest. Now, how can we do that on our calculator? Let's have a quick look. We would have to change the amount of interest we earn each month. So we can do that here by dividing that number by 12. We can fill that down. And lo and behold, right down the bottom here somewhere, we should get 562.72 if I've done it correctly. And there it is, 566.72, 717, or round to 72. And 2566.72, as expected. Now, could we have done that with the formula? Yes, we could have. A60, which is 5 years, is equal to A0, which is $2,000, times by 1 plus 5 divided by 12 divided by 100 to the power of 60, the number of periods required. And if we take our graphics calculator, we go, we'll do it here, $2,000 times by 1 plus 5 divided by 12 divided by 100, all to the power of 60. Lo and behold, we get 2566.72, which is the figure we get here. The interest would equal 2566.72 subtract 2000, which would be 566.72 as expected. And there you go. How to use your formula, how to use your spreadsheet to solve compound interest problems. And as I say, be really careful with how questions are asked, because if you don't change the rate and the time to how often it compounds, you will get the wrong answer. Thank you, everybody.